Hey guys, this morning we're going to do a lesson on the line of best fit in terms of scatter plots. So a line of best fit is a line that you can draw through the data points on your scatter plot, and it's going to best represent a linear relationship between the variables. In some cases, this is called a trend line, or another term for it is a regression line. So if you see any of those two terms, trend line or regression line, they mean the same thing as a line of best fit. So you may say, how do you find the line of best fit? The line of best fit is the line that is closest to each point. But if you have more varied points or they're more scattered around, it's much more difficult to find that line of best fit. Another term to kind of keep in mind is this one, the outlier. It is a point that lies further away from the main cluster of points, and in some cases it can cause inaccurate measurements, or it may just be an unusual but still valid point. So just be careful, because the outlier can kind of shift that line of best fit, and just be aware that that happens. Let's move to the example. So here's a quick example. Which line is the line of best fit, and justify your choice. So let's take a look at each one of them and kind of go through whether they're a good choice or not. So looking at graph A, I don't want that. Graph A. Notice that the line of best fit goes through most of the main cluster, but it kind of ignores those 2 points that are on the bottom. So in this case, it only follows the main cluster. Graph B, if you look at it, we can see that it's not in the main cluster, and it's not over with the outliers. It's kind of like smack dab in the middle. So it's like they've chosen to put the line right in the middle of that, but it doesn't really represent the data, because most of the data is far above that line. And so it doesn't make sense for the line to be right in the middle of those two things. It doesn't make sense to be in the middle of the cluster and the outlier. So it's in the middle of main cluster and outliers. Graph C, the line does go through almost the main cluster, but it is slightly shifted down a bit compared to graph A, and the shift down is probably because of those outliers. So graph C follows the main cluster with a small shift. Small shift towards the outliers. So in this case, if I had to choose which one is the best one, I would probably say graph C is the best line of best fit, or the one that best represents what's actually happening. Let's move on to the other page, and we'll see what's happening with those examples. Okay, so a line of best fit can also be used to estimate or predict values. If I asked you a question about the graph, estimating values that lie among the known values of the graph, or in between the data points that we are given, is called interpolation. I like to remember it because it has that in front of it, so it's inside the data. Predicting values that lie beyond the known values is called extrapolation. So that one's for outside. Usually this happens when you want to you have some data about what's happened per year and you want to predict maybe what's going to happen in 10 years from now, or what happened 10 years before. That's extrapolation because we're looking outside of our data. Let's see how this actually works. I'll show you how to graph the data. I'll show you how to draw the line of best fit, and I'm going to show you how to determine the equation of a line of best fit. It is a little bit of grade 10 math, so hopefully you've seen it before, but I'll just remind you on how to make that equation. Example, using a line of best fit to make predictions. These are the pre-exam term marks and exam marks for some students in a grade 12 math course. So I've given you some data there. We're going to graph the data and draw the line of best fit. We're going to determine the equation of the line of best fit, and we're going to use the data to predict a couple of different things. So let's start by graphing the data. So we're going to do these points. I'm just going to put on here 20, 40, 60, 80, and 100. And then I'm going to do the same thing on this side. And do 20, 40, 60, 80, and 100. Okay, so I graphed the points. Hopefully you guys tried to do the same, but they end up looking like this. Now, what you're going to do is, so we've graphed the data, we're going to draw the line of best fit. I'm going to, since they seem to go in an upward position, I'm going to draw the line like this. So notice how it goes through most of the points or is really close to most of the points. Now, in order to determine, so this is part A. For B, in order to determine the equation of the line of best fit, I always try to pick 2 points that are on the line, that actually go through the line. So I'm going to pick this point here, and I'm going to pick this one up here. Now, that means that I have the points 25, 29 and point 95, 96. So we're going to find the slope. That's the first thing to do. If you don't remember, it is y2 minus y1. So you would subtract the y's and then subtract the x's. So in this case, I'm going to do 96 minus 29 over 95 minus 25. And when I calculate that, I get 67 over 70. And then when I divide it, I get a slope that's 0.957. So that's my slope. Now, if you remember, the equation of a line is y equals mx plus b. So we found slope, that's this. And all we need to do then is find out the b value. In order to find the b value, we can put the slope in and one other point. We can choose one of our points that we had and then solve for b. So I'm going to use the first point. So 29 equals 0.957 25 plus b, and we'll solve for b. So I'll do some calculations. This is 29. This becomes 23.925 plus b. So I'm going to subtract the 23 from the 29. And I get 5.075 equals B. Now that kind of makes sense because it looks like the line's going to keep going and kind of hit around here, which is probably around that mark. That's our y-intercept. So we can have an equation that looks like this. 0.957 x plus 5.075. So part C and D want us to use the data to predict the exam marks. So for C, with a pre-exam term mark of 98. So you can use the graph and just go up to 98 and kind of follow it up to our line and see that it's going to be like 97 or 98. Or you can use the equation. And if you use the equation, you would just sub that in for our x value. So I'm going to put 98 there plus 5.075, and then I would calculate it. 97957 plus 5.075, and I get a mark that's 98.8, so it's approximately 99%. And you could do the same thing for D, except this time we're going to do 10%. Again, you can use the graph, or you can use the formula. And I'm going to use the formula just because I like to use the formula. Times 10 plus 5.075, and I get a mark that's about 15%. Okay, so that's why we would find the equation of the line and make some of those calculations better, especially when you have a graph like mine. It's not very, I wouldn't say it's completely accurate because it's not a graph paper and I wasn't very precise, which you guys should be. Last thing I just want to go over is this line of best fit works, but it doesn't always work. So sometimes we have data that isn't a linear model, and a linear model is unreliable if you have the following situations. So take a look for these. If the model is based on too few pieces of data, I wouldn't say that my model above is all that great because I don't feel like we had a lot of data. So keep in mind that that you want to have enough data so that the model is kind of more accurate. The model is based on data that are clustered together. There does not appear to be a correlation. So if they're completely scattered around, it's really hard to come up with a linear model. There are outliers, or the data does not appear to be linear. It could be that you plot all the data and it doesn't make a straight line. Maybe it goes up, kind of curving upwards. In that case, it's not a linear model. It would be something else. So just keep in mind when you're doing this that a linear model doesn't always work. Again, have fun with the practice and the quiz, and I'll see you guys later.